And we are back. Just one tiny more thing about JavaScript. We discussed some things in the break here, and I realized I didn't mention that jQuery actually not just makes things nicer and shorter for you to write, but they also, especially at the time, made things more predictable. In the sense that you had your different browsers, and they all had slightly annoyingly different implementations of the DOM. Now, the DOM is the document structure interface to your HTML page. So some functions or methods would work in one browser, and they would not work in another browser, or they would kind of work, or they would break unpredictably, or whatever. And jQuery, besides being this nice syntax format that you could write in and think in more easily, also just swept away all those differences. Of course, when we say some browsers here, at that point it was largely, some version of Internet Explorer or other, because it would tend to be. Nowadays, it's actually not that much anymore, and it might be good to sort of update your internal models there of who is usually the big culprit nowadays in being a different implementation of common things that you need on the web. Anyone has a guess? Yeah. Safari, yes, sometimes. It has been accused of being the new Internet Explorer in that one. But there's a bigger culprit. You have...
Not being WebKit, or?
You were about to say Safari as well. No, actually, old versions of Android browser. That browser actually doesn't really have a name. It's just sort of the Android browser, and that's not its name. It's just a way to refer to it. But if you have old Android devices that are stuck on an old Android version and never updating, it also has a really, really old browser with weird behaviors. I mean, it's weird just by virtue of not having been updated in the last few years, so it doesn't have new things. And jQuery compensates for that. And nowadays, when you go in and look in the jQuery source code, there are more compensations for old Android browser than for Internet Explorer. So we have a new sort of champion in town. Just want to say that. So things are much better today, but the landscape also looks different with mobile browsers and so on. And actually keep that in mind as we go forwards. The landscape does look different with mobile and with connectivity and with fast and slow connections and so on. We move on to our third implemental person here, Douglas Crockford. Now, this is the first important author, I would say. And not library author like John Resig, but author of books and also frequent giver of talks and presentations. And so Douglas Crockford has had a big influence on the JavaScript community simply by having a clear message, and something that we needed to hear as a community in the middle of the noughties, the previous decade. Here's his famous book, JavaScript, The Good Parts. And you may or may not see it, but it actually has the subtitle at the top here that says, Unearthing the Excellence of JavaScript. Now, it's a thin book, and that, is funny in itself. This picture has been made a number of times, where you have JavaScript, the definitive guide, thick book, and JavaScript, the good part, really, really thin. And yeah, I think it's important to laugh about that. And this photo is usually posted without a comment, like, yeah, look at this, you see for yourself. What are all the other parts? And several people have come up with this joke because it's so obvious. People who are involved with JavaScript tend to have these two books in their bookshelf, and sooner or later you realize this. But there's actually a really, really fundamental message in here, which is something like, if a language is big and has conceptual problems like JavaScript does with all its sort of early design mistakes and so on, you can still, by virtue of discipline, find the parts that are actually usable and sort of, in your mind, make a smaller language out of that and figure out how to use that smaller language to do everything you want and be a much happier programmer, because your discipline now takes you much further. You are avoiding the bad and dangerous parts, and you can do more by doing less. So this was actually quite revolutionary and influential, and I would say it was a message that the community needed. We were, in some sense, using too much of JavaScript, using some questionable parts or dangerous parts and so on. So the takeaway is we can make JavaScript better by using only the best parts of it. And it's a quick read. It's an afternoon's read, this JavaScript, the good parts. A little bit dated, I would say, but still very, very relevant for just starting to think about these things. Let's take some examples of what Crockford recommends in his book and then in later talks and so on, so that we can see what this is all about. The big one, I think, is double equals versus triple equals. This is about comparing things, okay? So JavaScript is one of the few languages that ends up with two comparison operators. It has the equals equals, which we call double equals, and it has the equals equals equals. Now, this is a historic thing, of course. The short one is the first one, which turned out to be undesirable or unreliable. It sometimes gives you a positive result when you expect a negative one. These things were actually not equals. And it's not a bug as such that it behaves that way. It's just that you can compare, for example, the number 5 to the string 5. And double equals is nice and compares across types. It says, yeah, these might be of different types, but they're sort of really the same thing. Triple equals doesn't do that. It first checks the types. See, are they even the same types? If they are not, this is a string and this is a number, then no, forget it. They are not equal. We do not do that. And so triple equals ends up being much, much more predictable. Here's a summary of what they do. So you have triple equal actually going down the diagonal here. That is, things are at most equal to themselves and to nothing else. That's what this table says. And then you have all these little boxes here with approximate equality. That's double equal coming in. And we can look at individual ones here. Look at, for example, the third row here with the number 1, and then after a while the string 1. So the number 1 is double equals equal to the string 1. And I mean, that makes sense in some context. Sometimes you want to sort of forget about the type and just compare things across the types. But usually you don't, it turns out. And usually it has more bad side effects than actually good benefits. And as you can see from this table, triple equals is really the predictable one, and double equals is sort of all over the place. We don't see the pattern there. We don't know why exactly these things turn out to be equal to each other. It gets even stranger, actually, as you sort of turn a mathematician's eye to this and try to analyze it, because in mathematics we have laws of transitivity, for example, when if A is equal to B and B is equal to C, then we would expect that A is also equal to C, because the equality relation sort of ties them all three together and makes them then all equal. But that doesn't hold with double equals. So you have, for example, 0 and empty string and the string false, which that holds for. Two of those are equal to each other, but the third combination is not equal. So you can get into really weird situations with double equals that you would not expect, that you do not expect from an equality relation. And again, we're running into the problem here that JavaScript is loosely typed. Sort of as you're looking at the program, you really do not know very much at all about the types of the things, the values in your variables. Of course, there are good explanation models for why double equals works the way it does. I don't want to sell it down the river completely. So if you color this table, you can actually start to put in explanations here, which is rather nice, actually. For example, the pink part here where number 1 was equal to string 1. They are equal because there we do a numeric conversion of the string. And according to some rule. Then we say, okay, that's a number in the string, then we need to numerically convert the string so we do get the same type, and then we can, triple equal compare them. And you see also that you have actually rather big yellow boxes here of strict identity, where double equals and triple equal actually behave the same. Then you have this flag-like band of null and undefined, which are special values, which are only equal to themselves and, as it happens, each other. There's no particularly good reason for that, but fine. Since they both represent sort of unknown or undefined values, they can compare double equals to each other too. And then out in the further reaches here, we have object identities, where we always create a new object. It's a new reference, and references are not equal to each other by default, unless you happen to hold the same reference twice, but you don't do that in this table. Whereas here we're converting these references to primitives, and then either to strings and to numbers, and they end up being equal to various things. For example, the empty array here ends up being equal to the number 0, because as it gets converted down to a primitive, something takes the length of the array, and the empty array has length 0, so 0 compares to 0. Things like that. So there are rational explanations for why double equals works the way it does. That still doesn't mean that it's sort of safe or good or sustainable to use. And so Crockford's message here was double equals is questionable, triple equals works every time. Use the one that works every time. All right. We'll come back to that attitude in general, but that's very probably the message that we needed in the last decade. Same thing with for statements. If you have a for loop in your old JavaScript code, that's probably wrong, simply because there are other better ways to do that. On arrays with sufficiently mature JavaScript versions, we can map over them, we can filter them, we can even do a for each over them, and that will behave in many senses better than just an ordinary for loop. And so again, the rule applies. Something works sort of half of the time or some of the time, but this other thing works all of the time, so use the thing that works all of the time. In the same way, Douglas Crockford recommends that if you have variables that you declare in your function, you should declare all of them at the top of your function, because the JavaScript language and the JavaScript compiler will actually treat them that way whether you want it or not. It will lift the variable declarations to the top of your function. So you can, for example, even mention a variable before it was declared, and that makes sense to JavaScript. So in order to avoid all that confusion, you just put them at the top yourself, and you make things clearer for yourself and for the next reader and so on. Now, this happens to be a rule that I personally don't agree with, and we can discuss that more later. But with the language that we had a decade ago, it kind of makes sense, and it can be argued for. I can see the argument for it, that you're making your code safer by applying this simple rule and doing the same thing that the JavaScript engine would do for you anyway. Then we're getting onto the territory of simple opinions of Douglas Crockford. He says, thou shalt not plus plus and minus minus variables. If you want to increase something by 1, you do the variable plus equals 1, because he thinks it's better. Now, he has an argument even here. He says that this kind of code is, it correlates with cleverness, and cleverness correlates with bugs. And you don't want to do that. So don't be clever, do it the long way, do plus equals 1, or find out a better way to write that piece of code. When you are tempted to do this, stop and think and do it some better way. I like those, so I tend not to listen to him at that point. But it's good to know that he thinks this, still, even today. So if we extract the policy from this, what Crockford is telling us, if a feature correlates with logical errors, if you know that you're using a feature that makes you more likely to put bugs in your program, don't use that feature. Use some other feature which is less bug prone. I mean, that makes sense on the face of it. That's the good parts. Use the good parts of the language, because, as Crockford loves to say, programming is already hard enough. Like, we don't want to deliberately put traps in front of ourselves when we code. We want to make things as simple as possible and as unlikely to produce faults as possible. In order to help you with all of this, Crockford also produced, again, many years ago, together with the book, this Jslint service. So you put your little script in here, and it comes back and basically yells at you for breaking his various rules. You can make it a little bit nicer by checking boxes here at the bottom, but not so much nicer. This is by far the most stern linter out there, and a little bit less popular today when there is competition in this niche. It used to say, I think, either on this very page or when you started reading the manual, it used to say, Jslint will hurt your feelings. And you get the idea. If you try it, you will see what it means. Because Crockford's aim here is not just to point out the things that are obviously wrong. His aim is to point out the things that could possibly be wrong, so that you write it according to the strict rules so that you never make a mistake. And that takes discipline. That takes real discipline. And I would say with the kind of JavaScript we were writing back then, around 2005, let's say, we needed that advice. And this was the level of the tooling we had back then as well. This was what you went to when you actually wanted to, start combing bugs out of your JavaScript. Crockford has said this, it's not actually a C-like language or a Java-like language, even despite the name. It's actually more like Lisp or Scheme than like C and Java. I don't agree 100% with that. I still think JavaScript is a very procedural language and that it shares a lot with C and Java. But I like the sentiment behind what he's saying. I like the approach that you take when you start thinking of JavaScript as not just, in the C or Java family. It actually has a real focus on the things that are associated with functional programming and so on. I personally wouldn't go so far as calling it a functional programming language, but it has those aspects. And as a Perl person, where we also have those functional aspects, I can be very happy with JavaScript because I can use it in those ways. Also important to know that Crockford, for all his sort of complaining and talk about discipline and so on, also introduced positive ideas in this. It's quite evident when you go and read the book, actually, with the good parts. For example, functions are very central and powerful. If there's one thing that JavaScript got so very right, it's the function abstraction. In fact, you could argue somewhat meanly that it's the only abstraction that JavaScript has, really. It doesn't, in early versions, it doesn't have classes or interfaces or modules or anything, but it does have functions. So what you end up doing if you want to sort of reach the higher levels of abstraction and actually use those ideas is to emulate all those things using functions. Not because that's nice code or not because that's entirely pleasant, but because you can, and it's the only tool by which you can do that. For example, one idea that Crockford champions is using closures to create a private space for an object. Ordinary objects in JavaScript are entirely public. Every method and every property in an object is reachable from the outside by anyone who cares to look at it. But if you return that object from inside of a function and you have methods in your object that reference things in the function, then those things will be private. So you can sort of emulate privacy here in a very clever way by using the closure mechanism that is already in JavaScript. So you do var foo or let foo in your function, and then you return the object, and the object has methods, and the methods sort of contain a reference to foo or use foo in some way. That variable foo cannot be reached from the outside. It was sort of created by the function. The function acts like a kind of object factory in this sense. Every time you call that function, you get a completely new object with its completely separate link to its completely separate variable foo. So it ends up being the moral equivalent of a private variable. That's a really cool trick to use. And I encourage everyone to sort of get to know that trick, because it's very powerful even in other languages that are not JavaScript. Crockford is also responsible for JSON. Now, JSON is simply the idea that JavaScript has something going on there with its simple values, numbers, strings, booleans, the null value, and then arrays and objects. If you combine all these and you allow a person to do anything they want with these, then you have a pretty good data format, actually. It sure beats the heck out of XML, which often ends up being twice as long and frustrating to read and write. And JSON just comes in as a fresh breath of air with the minimal amount of syntax to get the job done. So JSON is sort of kind of a subset of JavaScript. It's JavaScript written in a particular way, and you just keep the value. You have no variables and no statements or anything like that. And then you put the value in a file, or you transmit it across the network and so on. And that turns out to work really, really well. So I would say at this point, even though XML is far from dead, JSON has taken a big share of that mind share, definitely. And that's also Crockford's doing. He basically came up with JSON as part of some project and then published it on a web page, and now it's a thing, and now everyone's using it. During this decade, the 00s or the noughties, we also get some version development with JavaScript versions or ECMAScript versions. We sort of in the beginning landed on ES3. Everyone was using ES3 or slightly older, and that became a plateau for many, many years, basically that entire decade. And then ES4 is kind of, we don't talk about ES4. Because it was the first attempt for that committee to get some traction and get some evolution of the language. And they tried too hard. They wanted to put everything in. It became sort of a big, huge beast that tried to be everything for everybody. And the slogan, "Don't break the web," came up again, and it became a real problem. And you couldn't get anywhere in those committee meetings. So it was scrapped, basically. It was referred to as Harmony ES4, and at some point people just started over and said, this is not working, let's call it ES 3.1 and be much, much, much less ambitious. And ES 3.1 eventually evolved into ES 5 instead. So ES 4 was a dead end with sort of a lot of attractive ideas that eventually were resurrected in later versions, but that didn't take hold at that point. When we see the timeline as we do from today, we kind of see that ES4 was a missed boat. We could have gotten some nice things earlier, but we would probably have also gotten some, horrible committee decided kludges along the way too. So it's both good and bad that didn't lead anywhere. Nowadays, since about the turn of the decade, ES5 is the sort of new gold standard. And we can basically assume ES5 everywhere with very, very few exceptions. If we cannot assume ES5, we can at least assume ES3. And ES6, as you see, at this point, we are starting a yearly cadence here. So a new version of JavaScript is expected every year, a new version of ECMAScript. And so we have year numbers as well, besides the versions, and people are actually encouraged to use the year numbers. I still cannot make myself really do it. I think about it as ES6 and so on. It also frustrates me that if they had just waited a year to do that, then the one-digit number would sort of correspond, but they just couldn't wait, I guess. Maybe someday we will sort of catch up and come in sync. I want to talk a little bit about ES6 features later. But now ES5 is industry standard, and it's also, as nice as it is, we're now also getting used to those features, and they are starting to feel a little bit old, and that language is becoming a little bit limited. But at least we can assume that it's in virtually all the browsers, which helps a lot. Actually, speaking of browsers, one problem that we had for many, many years was that we were basically waiting for the market to kill off various browsers. Here you see, it's an old screenshot, people waiting for Internet Explorer 6 to die. Why do you wait for a browser to die? Well, again, because your visitors are using this horrible browser, and the browser can do next to nothing, or it does it in disgusting ways, or it leaks memory all over the place, or it crashes all the time when you use a certain feature and so on. So, and you've tried to fix this, and you tried inserting workarounds, and sometimes that works, sometimes it doesn't, and you just have to stay off using a nice feature that you want because of this this browser or other. And Internet Explorer 6 for a long while was the bane of many web developers for these reasons. It had a number of bad, unfixable things that just didn't go away. My favorite there was some company, I forget which one, but they actually did this. They were retailers. You could buy things online, and when you got to the checkout counter, they added sort of Internet Explorer 6 tax, and you got 10% extra that you had to pay because you were using this old browser. I love that. That's exactly the right approach to get people to sort of vote with their wallet and actually upgrade their browser. And then we waited for Internet Explorer 8 to die for much the same reasons, and there was a page for that as well. You don't hear things like this much anymore, and it's because of Evergreen browsers. And I really like this. It's, as far as I know, Chrome started with this. It's the idea that your browser is actually, of all the applications on your desktop, the browser is sort of guaranteed to be online because that's what you're using it for. So why shouldn't it just, like Ajax in the background, just go and get something? It just updates itself. The next time you start it, you're starting the new version. That's great. That's such a big progress. The easiest way to get people to have fresh browsers is to do the work for them so that they don't have to go and install something new. I mean, obviously, in retrospect. And similar dynamics, though not exactly the same, when you have a mobile device and you actually sometimes update your apps and so on. So nowadays we're in a much, much better situation where new JavaScript features and other new web features can actually roll out on a schedule of months instead of years or decades. The next person we're going to mention is right across the Öresund waters here, Lars Bak, not the Danish cyclist, but the Danish compiler developer. Lars Bak came up with a new engine in connection with the Chrome browser, which is called V8. So now we're up to September 2008 here. V8 was revolutionary in that it did things to JavaScript that no one had thought about doing earlier. And this is one of those mental blockers again. JavaScript is a scripting language, right? It's an interpreted language. So what can you do? Everything is so dynamic that you basically cannot optimize it. But V8 could. And this was a total game changer. We're talking about the kind of compilation of the language which makes it, so to speak, close to the metal. I mean, some of the time when you're running V8, you're actually interpreting instructions and everything is nice and slow as in the old days. But sometimes the just-in-time compiler kicks in and says, hey, I see you've run this function here like 150 times. How about I go in and take what I know about the dynamic runtime process and think of those patterns that I see as actual constraints. I see, like, out of those 150 times, you've passed a string in here exactly 150 times. So I'm just going to make that a rule. Now it's a string. In my compiled code, it's a string. And it compiles it down to machine code. The machine code is really nice and fast. It runs directly on your machine. And it has some nice, some simple check as well, because you have to, if at any point it's not a string being passed in, you sort of get a penalty and it uncompiles it and go back to interpreting it again. But probably not, Probably you've been a good programmer and you always pass in a string there and you always get the fast version. Reasoning like that made V8 a completely different JavaScript runtime engine than anything before. And it just blew every other engine out of the water, and suddenly everyone except Google said, oh shit, we need to do this also. We need to make our jitted JavaScript engines so that we are not, 100 or 1,000 times slower than JavaScript on Chrome. So that was important. Another thing that, just talking about these nice optimizations that V8 does, is it guesses the shapes of your objects, which is, everything is so dynamic in JavaScript. You can add and remove properties and sort of change their type and so on as you go along. But usually in a fairly sane JavaScript program, you will have an object that looks the same from the start, and you just update some properties along the way. But the shape stays the same, and it's predictable, and you can use it as part of your analysis in making the program faster. It's called, I think, pseudo classes or something like that. So it's not real classes in the JavaScript language at this point, but V8 creates a pseudo class when it sees what you're doing with the object. And then again, there are various kinds of things that you can do to slow things down again. For example, if you use the delete keyword that we saw for arrays, if you use that on an object and delete a property, all the nice optimizations go away all of a sudden because you've changed the shape of the object and all bets are off. So this was really, really important. And so by extension, the whole image of JavaScript now needed to change. If it can be fast, then it can also be, a serious language, and it can also be used in the enterprise. Maybe we can do something with this. Maybe we have to do something with this. And so the next person steps on the scene, Ryan Dahl, and his idea is simply to take JavaScript out of the browser. We say, we can run JavaScript, for example, on the server or in your local development environment or on a small embedded device or whatever you want, because this V8 thing, sure, it's sitting in Chrome, but it really doesn't have to. It's a JavaScript runtime. It's fairly fast. We run it wherever we want. And that was a big thing in itself. This wasn't Ryan Dahl's only idea, though, and it's really good that it wasn't, because asynchronous programming turned out to be a big topic for this decade. Just to remind everyone, when you have synchronous programming, you make a function call and everything stops. Sort of execution goes into that function, and you come back out and you continue with the rest of the program, but the rest of the program has had to stop and wait for that function to finish. This is all fine and good and well in a non-networked environment, but in a networked environment, just like when you call for a pizza, you don't expect to stay on the line until they finished your pizza and delivered it. You cannot afford that kind of locking. That also goes on the network. A node which makes an AJAX call, for example, expects to be able to do things while the request goes out, processing happens on the other end, and the response comes back. You don't even know if you will get a proper response. Maybe you will get an error. And so you install handlers for these things and do things that way. And Node.js, unlike JavaScript, was designed with this in mind from the start. So if you want to request a file from the file system, the default function to do this was asynchronous. So you started programming in an asynchronous style. And actually, Ryan Dahl made a little bit of a bet on this. The way you do it in default Node.js is to pass the handler. What happens when this result comes back? You pass that as a nested function, as an argument to your get the contents of this file function or whatever. So you end up passing a lot of functions into functions, and your program ends up being very, very nested. And it's, to be honest, not very pleasant to look at. People started talking about the pyramid of doom because your code got more and more indented, and then it got less and less indented, and people started swearing about missing a closing brace or a comma somewhere or a semicolon, and you at least needed a really good editor to keep track of everything for you and not go crazy along the way. The pyramid of doom is a little bit of a red herring. The actual problem with nesting functions in functions like that is that we lose the normal nice conveniences of the ordinary JavaScript language, such as try-catch statements or breaking out of a loop or something like that, because your primary idiom now is just passing functions into functions all the time. You shadow yourself from the rest of the language, and you make the language a little bit weaker and more narrow by doing that. Nowadays, we know a much more pleasant way to do this. It's called promises, and it's a sort of standard or an API that has and a specification that has evolved across the years. But that wasn't available back when Node started. So this was probably a good bet actually to do. That Ryan Dahl did. And nowadays, if we want to use the new fancy promises style, and we probably do want that, it's super trivial to just take all the existing continuation passing style functions and just auto-convert them to promise usings. So that's what people do nowadays. So it was a good bet, actually, not to settle on some, half-useless proto-version of promises that wouldn't be valid today, but to do it sort of built into the language, even though it wasn't perfect. Node.js also brought in a lot of other nice things. Since we were now using JavaScript in our development environment, we could start thinking in terms of build toolchains. It's everything like, maybe we want to tweak our program a little bit along the way before we show it in the browser. Maybe we want to bundle 10 or 20 or 100 JavaScript files into one single file and just import that one from the HTML. It's also things like linting. Linting in the past year has been the big eye-opener for me. I used to have sort of a healthy skepticism for linting and say, sure, it's good, but I already write pretty good code, so I don't need that. Well, it turns out that if you have a linter, it actually does find a lot of things for you that are worthwhile to point out. The only prerequisite to this is that you need to go in and configure the linting rules. You need to make them work for you. You shouldn't take someone else's preferences and run with them, because then you will go crazy and you feel boxed in. But if you actually put in the effort to get good linting rules, then they will pay off handsomely for you. So highly, highly recommended. In terms of the single simple thing you can do to raise the quality of your entire code base, do install a linter. As you gradually turn on the rules, you also gradually go in and fix the errors that they are reporting. Very, very nice. And this, again, this is based on the assumption that we have a build toolchain in the background, that we don't just write a lot of JavaScript and dump it in the browser directly. We have something in between that processes things for us. We now enter our own decade, which is not finished yet, but which also already contains gems such as Korean music video Oppa Gangnam Style. My 2-year-old son is crazy about this one, and I understand him. So now we have a build toolchain that is extremely valuable. It brings a big mind shift in that, hey, we can compile our JavaScript. We never thought about this before because it was a scripting language, okay? This completely solves the problem of having to write old JavaScript because someone might run it on their browser. Now you write new, nice JavaScript. You have it compiled back to base level, lowest common denominator, works everywhere JavaScript, which you basically don't have to look at. But that just runs in the browser. So you have sort of a JavaScript to JavaScript compiler. Because people in the web front-end world are hipsters, they have invented a word for this called a transpiler, which you will hear sometimes. Those of us who sort of know our history with compilers and so on, we know that a transpiler just means compiler, comma, and you can stop listening now because I don't know what I'm talking about. But that has been very, very valuable. CoffeeScript was one of the early languages that said, hey, let's refurbish JavaScript and write it the way we want it, like some nice combination of Python and Ruby, and then it just compiles down to JavaScript. Nowadays, the demand for CoffeeScript is less. It hasn't completely died out yet, but actually the rest of ordinary JavaScript and other nice languages have caught up. So they've started invading this niche. And there's literally hundreds of languages that now compile to JavaScript that you can do this with. But I would say the most important one of them today is newer JavaScript, Newschool JavaScript that you write so that you can run the lowest common denominator code in your browser. And someone might say, hey, wait a minute. This sounds like a pipe dream because I know, with the sort of pessimist or realist that I am, that I will have to debug that generated code, and that's horrible. And actually, no, that problem was solved also along the way. There's something called source maps, which get shipped along with when your code gets compiled, and that generated code that you never have to look at lands in your browser. There's also a source map saying, hey, all this generated code, there are sort of arrows or pointers back to the code that you wrote, your original code. And so when the debugging session turns up, either in your browser or in your IDE, you actually end up in your original authored code. As long as this mapping file works perfectly, and it tends to work really, really well, actually, you're fine. You don't have to look at the generated code. So that's a really nice solution. Last person on the list, Kyle Simpson. This is another author, and he's also on Twitter, and I would say is fairly influential. You can see that by the fact that his GitHub project has many, many stars. I don't know what top 10 or something like that is. It's one of the most popular JavaScript projects out there, JavaScript related projects out there. And it's not even code, it's a book, or it's a series of books. It's called You Don't Know JavaScript, which, yes, it's a provocative title, for sure, but it actually has a bit of a story behind it as well. Kyle was on an interview where he basically, in the interview itself, got rejected because it was felt that he didn't know JavaScript enough. And sure, his first reaction was, what? Sure, I know JavaScript. That's ridiculous. That's very mean of you to say. And then he thought for a while, actually, and he thought, hey, I've never actually studied this language in depth. I've never actually taken the time to sit down with JavaScript and really, really go through it and really, really understand it. And isn't that strange? I mean, a language that I use every day and then that sort of my bread and butter, I haven't looked at it, really. So this Kickstarter funded book series was his effort to do that for himself and for everyone else. And of course, it's well worth reading. And it's free online, or you can buy the books and then you pay for the dead trees. But do read it, really. It's longer than JavaScript, the good parts, and there is some photo out there which I didn't include, but where these books sort of stack up to the big thick book as well. So then you know approximately how much there is to read as well. But really, really nice. It goes through things like the compilation process, variable scopes, how do types work, how do grammars work, how do operators work, and so on. These promised things that we talk about, what's the advantage and disadvantage compared to just passing functions to functions. All that and much, much more is in these books. I could not recommend them strongly enough. If you have one takeaway from this talk, is that you need to read these books because none of us know JavaScript. Also, it's kind of a nice counterpoint to the stern prescriptivism of Crockford here, where Crockford said, only use these parts because these parts are the only thing that are good. Kyle says, learn all the parts. Really, because whether it's in there because it was a mistake or it's in there because it's a great feature, it's part of your tool set when you have chosen JavaScript as a language, and you should be familiar with it. You can find it in someone else's code, or you can find a safe, healthy way to use it, even though it's a potentially dangerous feature. So now sort of all doors open, and we get challenged to use JavaScript in nice and productive ways. He says this, I gently challenge you to journey down that bumpy road less traveled and embrace all that JavaScript is and can do. With that knowledge, no technique, no framework, no popular buzzword acronym of the week will be beyond your understanding. Now, doesn't that sound nice? So let's finish up by talking a little bit about the emerging present and the future with ECMA Script 6. So ECMA Script 6 is the last version that has started rolling in and entering people's lives. And we at Edument have been really happy to embrace the ECMA Script 6 features, for example. And nowadays we think about our courses as they should be about this, because anything older than that will just gradually go away, and we should prepare people for the environment that's now sort of spreading out. Again, that's especially true because of these compiler toolchains, where you get that today, no questions asked. The browsers can be as old as they like, you can still compile down to something that everyone can use. Of course, you have to prepare for that. You have to see what environment you're in and at the least have a build toolchain. So we started phrasing the debate as old school JavaScript, which is ECMA Script 5 and lower, versus new school JavaScript, which is ECMA Script 6 and higher. And that has been very fruitful for us for thinking about this, how to present it and introduce it. One thing you notice immediately is that ECMA Script 6 comes with a lot of new syntax. I mean, people also always notice the syntax before anything else. Even though it's just surface, that's what you notice. And in ECMAScript 6, probably more than any other earlier version, a lot of cruft goes away. So it is actually an important comparison to do, an important thing to notice. I prepared a short example for you here to see that. Here I just wanted to compute the average of these 5 values down here, and we don't have to do a lot of math to see that 30 will fall out of that. We sort of sum all those up and we divide by the number of items, which is 5. But in old school JavaScript, we have to write all this code above here, and you can already see here that something is not quite right, that we have to write all that much code just to take the average between some numbers. So we're going to gradually massage this code and make it right, okay? But I have to stop here and explore and explain a little bit all the damage or all the workarounds that we needed to put into an old school JavaScript code base. And again, this is with the goal to make you sort of appreciate this and then never have to write it, because nowadays there are better alternatives. You should write new school JavaScript, and that's what we say in our courses. And there are ways to do that, even if you're in an organization where people are generally skeptic to change and improvements and so on. So here's what's going on. We can look at the sum function first. Our goal is simply to run through all of the arguments that are coming in and to add them to each other. That's easy. But you see also that the parenthesis after sum is empty, because we don't know how many arguments that we are expecting. It could be 5, like in this case, or it could be 0, or it could be 100. It's sort of variable. It's a var arg. So instead what happens is that we're sort of listening into a magical variable inside this function called arguments. That's the array of our arguments. Whatever we do up in the actual parameter list there with the function declaration, our arguments will sit in the array arguments. Good. So what we want to do with it is to loop over this array, but then we have the problem in old school JavaScript that arguments is not actually a real array. Again, because of early language mistakes. It should have been a real array, but it isn't. It's a so-called pseudo array. It's a sort of not quite an array. So the first thing we need to do is clone it. How do you clone an array? Well, you call slice on it. But we're in a sort of catch-22, because since it's not a real array, then it doesn't have a slice method. So we need to go to the array type, pick out the slice method and say, hey, this method here, I want to call it, sort of transplant it on the arguments object and call it there. So that's what this whole strange line is doing there, just to combine the right method from the right type with the arguments pseudo array, so that we get a clone of it, so that that clone actually has a for each method, so that we can loop over it. It's kind of like a sort of multiple steps to get to a simple result here. inside this function, which runs for each element here, the element e, we just add that to the result, and then we return the result, and we're done. Now, the actual function we're calling, the average function, kind of has a relatively easy time, because it just needs to delegate to the sum function here, and then divide by the number of arguments, right? And arguments is enough of an array that it has an argument's length. If you're wondering what's going on with call here, it's kind of like the trick with apply here. That's our way in old school JavaScript to pass a variable number of arguments. So we're basically just taking arguments as our input, but we're also passing it on to the sum function here. So call is just a special way to call something with a variable number of arguments. And you'll be delighted to know that this is one of the damages that will go away in the next few slides. First simple thing that we do, we no longer write var like we do up there with result and numbers, we write let instead. And you see that immediately our IDE stopped complaining about them and didn't highlight them in yellow. Let has the nice behavior that it doesn't hoist your variable declarations to the top of the function, which we heard Crockford warn about. It just keeps them where they are, and they are a lot more predictable. Nice. So that was a simple change. Next up, we start using the power of arrow functions. And you just saw something small change here. That was an anonymous function here that we needed for the loop body. Now we can just write it in a much nicer, shorter way. We say, E coming in here, arrow, this is the end result. We've skipped a lot of things. We skipped the parentheses around the incoming parameters because we only have the one, so we can skip it. We skipped the braces around the function body, and we skipped the return because it's sort of implicit. And so we just have, this is what people sometimes call a lambda in other languages. Very nice to write. It's still a function in JavaScript, it's just with a different syntax and tinily slightly different behavior that doesn't matter here. And so we call it an arrow function, but it's really a lambda. So that's nicer and shorter. Next up, we exploit the fact that we now have a mechanism to take a variable number of arguments, both as we call a function and as we declare a function. So these ... says simply, now at this point we just slurp up the rest of the arguments that are coming in. And we do that as the first thing here, so it's going to get all of the arguments, right? So this numbers array that we needed to clone arguments into, now we can just put that in the parameter list here, saying sum of some unknown array of numbers here coming in. And so it still looks the same on the caller side. We still pass in 10, 20, 30, 40, 50, but that will end up in this array numbers just automatically. And you see all the pain and damage of dealing with arguments just went away by that. It's like now we have a good, sensible name for arguments in our function. It's called numbers because we wanted to. One tiny detail, you see this both on the declaration side when we declare the function and on the calling side. It's very suggested that it's exactly the same syntax, but as you think about it, they mean two different things. Here it means take a variable number of parameters in and make an array out of that. Here it means pass an array and sort of spread it out in the argument list as several individual arguments that are also variable. And that's two different things. But of course, it makes a lot of sense to have the same syntax for it because we're sort of doing it in two ends, sort of on the caller end and on the callee end. And that's nice. And we could stop here, actually. This is a nice implementation of sum. But now that we see that it's just these three lines, it's kind of a pattern. Initialize something to 0, and then pass through each number here and take sort of the last best result so far and do something with it, sort of add something to it, and then return that eventual thing. Then we might think back and say, hey, this is a reduce, so we can just call the reduce method on arrays. And that's actually even from ES5, so we could do that in ES5 if we wanted. We again use a lambda function here. Reduce conceptually takes a big array of things and turns the commas that are separating the elements into some operator or other. So here we replace the commas with pluses, which is exactly what we want to do here, right? We want to do 10 plus 20 plus 30 plus 40 plus 50 in this code. And the 0 here is just the equivalent of saying results should start at 0. We need a starting point to get this process going, sort of when to start plussing things. Now we are home. This is the code we want to write, always. And once you start writing code to this, it's like this. It's very, very difficult to go back to the old damaged way. It would have to be extremely special circumstances for me to want to voluntarily sit down and write old school JavaScript again, because I like this. It's not brain damaged. So what we see is JavaScript actually now having a process for successfully improving itself. And there are a lot of components that contribute to this. Of course, it's the fact that the committee work now actually is successful, and they manage to produce new versions of the spec and so on. And it's actually rather impressive when you start to look into how they do that. You start at level 0 with a strawman proposal, and then that proposal gets more and more mature along levels 1 and 2 and 3 and so on, and eventually it ends up in the spec. But it's sort of unknown how long this will take, or if it will ever finish. If it will encounter conceptual problems or implementation problems along the way. So we have a number of sort of future proposals sitting around, and I will mention some of them here before we finish for the day, which we simply don't know. We're pretty sure that they will turn up in JavaScript, but we're not always sure when. But that also doesn't matter, because as long as we can compile back to old school JavaScript, we can still use it in our code bases without virtually any risk, and that's cool. So the committee work is one part of that. Evergreen browsers is another part of it, that we can be fairly sure that the browser vendors are working hard at making these features actually be included in the browsers, and the baseline keeps rising, lifting all the boats and all the users at a fairly steady pace nowadays. And that's very important too. Also, we all together as a community know much more about JavaScript nowadays, and we know how to use it better. And it's like the community process from Crockford to Kyle Simpson has been about discovering what JavaScript actually is, now that we accidentally created it in our browsers. So just a couple of future features that we are expecting. This one is kind of nice. Now that we talked about the REST parameters, this is the same thing but for objects. So let's say I want to create an object here, and I want to put an unknown number of property value pairs inside of that object. Just basically spread them out inside of this one. Then I can do that with also the ... syntax. But don't expect that to work in ES6 again. You need to sort of special add-ons in your environment to make this work today. But it does work. We're saying basically spread out the entire contents of the default options object here, and then go on to pour in another object in just the same way and spread them out. And if that one contained 3 properties and that one contained 5 properties and they didn't collide, then you get 8 in total. If they start to collide, if there's a conflict here, then last one wins, which makes sense. So you can use this as a sort of default mechanism. Here are your default options that you get if you don't provide any conflicting ones, and here are the ones that are perhaps passed in as parameters to the function or something. That works really, really well. And in some sorts of code, especially React code or React Redux code, this is a lifesaver. It just makes your code so much nicer and cleaner. So that's something we all are looking forward to, I would say. Another thing that is on the timeline, but not sure exactly when it will land, is being able to decorate class declarations. I have not talked particularly about class declarations, but they are another ECMAScript 6 feature. When you look under the hood of classes, they are nothing but syntactic sugar for a certain way to use functions, of course, because it's JavaScript. But there's also a need for sort of a declarative way to hang sort of metadata onto this class, especially in projects like Angular 2, which we are nowadays supposed to call it's just Angular instead of Angular 2. But they use the component syntax. And so they are a little bit ahead of the curve, simply because in their world it makes a lot of sense to use this feature. If you've ever used annotations or decorators in Java and C#, this makes some sort of sense for the same reasons. And finally, we are doing one better even than promises, where promises allow you to sort of sequentially specify, we're going to make a web request, it's going to come back, then we're going to run some code, and then we wait some more, and then we run some more code, and so on. That's still method calls that you keep chaining, kind of in a jQuery-like way. Async await simply blends this into the code itself. So you can write completely ordinary code with 2 extra keywords. You say this is an asynchronous function, which means it pauses sometimes. It hits the pause button and lets other functions do its thing. And those pauses are indicated by await here, which simply say, here is hidden all the code that you needed to do with saying, and then do something else when the result comes back. It just blends away in this, and you get to write seemingly completely normal synchronous code, though it's actually asynchronous. And that's going to be a big deal, because it's going to just lift our that weight from our shoulders, and the code is nicer and easier to look at and nicer and easier to reason about. Especially when you think of things like try-catch statements and so on, they will still keep working with that kind of code instead of doing big dances with either continuation passing style or promises. Very, very nice and very important. This is a borrowed slide from Brendan Eich, who has long been touting this line, always bet on JavaScript. They said so many things about JavaScript, how it wouldn't be fast, how it couldn't be fixed feature-wise, how it couldn't do multi-core GPU or other interesting exotic architecture. And people have been wrong every time in betting against JavaScript. So my advice is always to bet on JavaScript, because JavaScript has, in some sense, already taken over. This is where I plug our course, where we will talk about exactly these things and much, much more. The specifics of how you get to know JavaScript and how you become a JavaScript. I was almost saying ninja there, but ninja is code for adequate programmer. So a JavaScript, a person who knows JavaScript really well, because JavaScript has already won. So that's very important. Thank you. And if there are any questions, I would be very happy to take them now. Right. There we go. Does anyone have any questions? I got a question earlier about objects, which I really, really liked. And I haven't specifically talked about objects, though JavaScript has a fascinating object story, which basically is about JavaScript not initially doing anything with classes. So all the other object-oriented languages, more or less, had objects and classes, and they did them together, and you couldn't think of objects without also thinking about classes. In JavaScript, in order to understand objects well in JavaScript, you have to sort of think about it without classes. And that's pretty cool, actually. That's a sort of new view on objects. And if you treat that right, it can open your eyes to how dynamic that can be and how we can think about it in new ways. Questions? All right. Again, thank you.
Thank you.